future hackers. In today's video, we'll dive into the fascinating world of steganography using a tool called Steghide. Steganography is the art of hiding information inside files, such as images or audio, without visibly altering them. It's a great way to conceal secret messages or files. Using Steghide, I'll show you step-by-step how to embed and extract hidden data from a file. By the end of this video, you'll have a clear understanding of how this tool works. So let's get started. Before we begin, we need to ensure that Steghide is installed on our system. If you're using a Linux-based OS like Kali or Ubuntu, you can install Steghide using this command. Type Y to continue the installation. Installation of Steghide is completed now. Now type Steghide to check whether it is installed or not. We can see that Steghide is installed successfully. We're ready to jump into the practical part. Here I have two files ready. Cover.jpg. This is the image we'll use as our carrier file to hide the data. Secret.txt. This text file contains a secret message we want to embed. Let's take a quick look at the content of secret.txt. Alright, now we're ready to hide this text file inside the image. To embed the secret.txt file into the cover.jpg image, we'll use the command that is on the screen. Let me break it down for you. CF specifies the carrier file, which is cover.jpg. EF specifies the file to embed, which is secret.txt. P is a password used to encrypt the hidden data. Here, I'm using my password as the password. Now hit the Enter button to run the command. As you can see, Steghide has successfully embedded the data. The output says, Embedding done. Now that the data is hidden, let's verify whether the image contains any embedded data. We'll use the following command. After running the Steghide info cover.jpg command, we can see detailed information about our carrier file. It shows the file's format, its capacity for hiding data, and confirms the presence of an embedded file. Once we enter the correct passphrase, it reveals details about the hidden file, including its size, encryption algorithm, and compression status. This is a great example of how Steghide ensures both security and efficiency while hiding sensitive information. To extract the hidden data, we'll use the following command. Let me explain. SF specifies the Stego file, which is cover.jpg. P is a password we used earlier, which is my password. Now hit the Enter button. Oops, I made a small error here. Instead of typing JPEG, I accidentally typed JPG. It's a common slip, especially since both terms are often used interchangeably in everyday conversations about images. However, for Steghide to work correctly, the file extension must exactly match the actual file type. Let me quickly fix this and re-enter the correct command using JPEG. Remember, paying attention to such details is crucial when working with tools like this. Now, when I run the extraction command, it's asking whether I want to overwrite the existing secret.txt file. This happens because a file with the same name already exists in the current directory. To avoid any confusion or accidental data loss, it's always good to check if you need to keep the existing file. You can either rename the old file or proceed with the overwrite if you're sure it's not needed. For this demonstration, I'll allow the overwrite by confirming with Y. Since secret.txt already exists, I'll remove it to demonstrate the extraction process clearly. After deleting the file, I'll rerun the command so you can see how Steghide recreates it during extraction. Now that the extraction is complete, we can view the contents of the secret.txt file using the cat command. We can see that the message from the secret.txt file is displayed successfully. That's all about the Steghide tool. We've successfully learned how to embed files securely within an image or other media, as well as how to extract and view hidden files.